It would detonate and obliterate all of New York City, parts of Connecticut, and New Jersey. This is, maybe, quite possibly one of the greatest secrets in our material science. Betelgeuse, a grand miracle gracing the night sky, is a famous, red, exceptionally monstrous supergiant star. It resides in the Orion constellation, astounding stargazers for quite some time. Recent warnings from renowned physicist Michio Kaku have raised concerns, suggesting that Betelgeuse might have finally exploded. What this means for reshaping our understanding of stellar life cycles and the forces shaping our universe is an imperative question. What insights does it hold for us? Stay tuned to find out. Imagine looking at the night sky and seeing an extraordinary star in the Orion constellation. Betelgeuse, also called Alpha Orionis, is a massive, brilliant star located at around 5 hours 30 minutes right ascension and 0 degrees declination. Its name originates from the Arabic term meaning, the giant's shoulder. In 1603, astronomer Johann Bayer gave the star its unique name, Alpha Orionis, suggesting its prominence as the most conspicuous star in the Orion constellation. Interestingly, despite being considered the most prominent star in Orion, Betelgeuse proudly holds its name as a red supergiant. Betelgeuse is a massive star, several times larger than our Sun, making it a true giant compared to our solar system. To put it into perspective, if the Sun were a small marble, Betelgeuse would be a colossal ball. Determining Betelgeuse's distance has been challenging, with measurements placing it somewhere between 500 and 600 light-years from our Sun, a vast distance in astronomical terms. In terms of brightness, Betelgeuse shines with an apparent magnitude of around 0.6. Harvard professor Morgan McLeod noted that Betelgeuse's size and proximity make it one of the few stars that astronomers can closely study using telescopes both on Earth and in space. Telescope images reveal Betelgeuse's unique characteristics, showing a surface distinct from the smooth appearance of our Sun. Instead of a uniform sphere of hot plasma, Betelgeuse appears as a collection of uneven, frothing gas pockets, some almost as large as smaller stars. Gigantic emissions of hot material rise from Betelgeuse's outer layers, resembling massive spring cleaning. One such ejection is so immense that traveling at the speed of light would require 75 years to cross it. This phenomenon, known as surface mass ejection, releases material from Betelgeuse's outer layers, similar to the Sun's coronal mass ejections. These ejections are not consistent but vary with Betelgeuse's internal cycles. At just 10 million years old, Betelgeuse is astonishingly young compared to our Sun. Despite its youth, Betelgeuse has already burned through much of its hydrogen fuel in its core, entering the later stages of its life as it transitions into the red supergiant phase. During this stage, Betelgeuse fuses helium to create carbon through nuclear fusion, driving rapid, dramatic changes fueled by its enormous initial mass. Scientists suggest that Betelgeuse began its life as a blue-white type star, belonging to the largest group of hydrogen-burning main sequence stars. The size of stars directly correlates with their brightness and energy output. Larger stars like Betelgeuse shine more brightly and burn more fiercely. However, this also leads to faster hydrogen consumption and an earlier transition to the red supergiant phase. Betelgeuse's surface reaches stunning temperatures of up to 8,950 degrees Fahrenheit, a sharp contrast to our Sun's cooler 10,000 degrees Fahrenheit. As Betelgeuse consumed its hydrogen and began fusing helium, its outer layer expanded dramatically, making it one of the largest stars known, with a diameter greater than 700 million miles. Currently, Betelgeuse's surface temperature is around 5,800 degrees Fahrenheit, cooler than the Sun, yet vastly more luminous, being 7,500 to 10,000 times brighter. In 1836, astronomer John Herschel noted changes in Betelgeuse's brightness, leading to its classification as a semi-regular variable star, with irregular changes and periodic fluctuations generally following a 400-day cycle. In 2019, Betelgeuse exhibited an anomaly, deviating from its typical behavior. Its brightness fluctuated, following a consistent 400-day pattern, peaking at a magnitude of 1.3 before dropping to around 2.8. These fluctuations were linked to its photosphere, the star's outermost layer, which emits most of its light and heat. Convective movements in the photosphere, where heat transfers from the interior to the surface via gases, cause brightness variations over time. During the fall of 2019, Betelgeuse experienced a massive dimming of about 60%, marking a departure from its usual pattern. The cause was a vast release of material that formed an enormous dust cloud, obscuring our direct view of the star. Although the dust cloud eventually dissipated, Betelgeuse hasn't fully returned to its previous state, and its 400-day brightness cycle has shortened to just 200 days. Betelgeuse's erratic behavior has sparked discussions about the potential for an imminent supernova explosion. In a supernova, as the star exhausts its remaining fuel, its core collapses, leading to the formation of a black hole, while its outer layers are ejected at speeds of up to 25,000 kilometers per second. If Betelgeuse were to undergo a supernova, it would be a spectacular celestial event visible even during the day. If Betelgeuse were to go supernova, it would shine as brightly as a full moon in the night sky and remain visible for weeks, perhaps even months. The explosion would release a tremendous amount of energy, illuminating the surrounding cosmic landscape and enriching it with heavy elements like gold and uranium, essential components for forming planets and life. Fortunately, Betelgeuse's distance from Earth, approximately 500 to 600 light-years, ensures that any harmful radiation released by the supernova would dissipate long before reaching us. However, it would provide a rare opportunity for scientists to study a stellar explosion in unprecedented detail, offering critical insights into the life and death of massive stars. The timeline for this event, though, is uncertain. While Betelgeuse appears to be nearing the end of its life, near in cosmic terms could mean tomorrow, or thousands of years from now. Observations of its unusual dimming and irregular behavior in recent years have led scientists to closely monitor the star, with some speculating that the supernova might happen sooner rather than later. Beyond the scientific implications, the potential supernova of Betelgeuse holds a profound cultural and philosophical significance. For millennia, humanity has gazed at the stars, weaving myths and legends around celestial phenomena. Betelgeuse, as a key feature of the Orion constellation, has inspired countless stories across cultures. Its transformation would not only alter the night sky but also shift our perception of the universe's dynamic nature. For now, Betelgeuse remains a mystery, an aging giant teetering on the brink of a spectacular finale. Astronomers continue to watch its every move, using advanced telescopes and observatories to capture its ongoing changes. Whether it's next week, next century, or beyond, the day Betelgeuse finally goes supernova will mark one of the most awe-inspiring cosmic events humanity has ever witnessed. Until then, the enigmatic red star continues to shine, reminding us of the vast, ever-changing nature of the universe and our place within it. Tremendous occasion noticeable for quite a long time, similar to the full moon. Given its vicinity of only 650 light-years, it would be one of the most brilliant supernovae ever observed. While star blasts are common, they're usually too far away to be seen without powerful telescopes. This makes Betelgeuse's potential supernova a significant event for skywatchers. As stars age, their cores accumulate iron, eventually triggering a supernova. The most recent supernova visible to the naked eye, SN 1987A, occurred in 1987, around 168,000 light-years away. Although this event was visible to the naked eye and provided immense insights into stellar evolution, its distance from Earth meant it had little effect on our planet. Betelgeuse, a star at the center of attention, is expected to go supernova. Astronomer Miguel Montarges, an expert on Betelgeuse, predicts that its brightness will rise to that of the full moon when the supernova occurs. Picture a captivating 2-month period where, on a starry night in a dark city, you could read a book lit by Betelgeuse's supernova. In 2021, Betelgeuse experienced another dimming event, similar to the 2019 anomaly, with a 60% reduction in brightness caused by a cloud within the star's wind. This cloud obscured part of the star, leading to a missing southern hemisphere in images. After this dimming event, Betelgeuse unexpectedly brightened, but the cause of the increase remains unclear, prompting further speculation among astronomers. Betelgeuse, now 15 to 20 times the size of the Sun, falls into the category of stars expected to go supernova. Astronomers generally suggest that Betelgeuse could explode within the next 100,000 years. However, a recent study by Hideyuki Seo and colleagues from Tohoku University suggests that the star might be closer to exploding than previously thought. Seo's team bases their hypothesis on Betelgeuse's behavior of consistently expanding and contracting with occasional hints of instability. While they don't predict an imminent explosion, they suggest it could occur within the next 1,000 years, challenging previous timelines. The uncertainty surrounding Betelgeuse's timeline has captured the interest of astronomers. However, some scientists argue that stars like Betelgeuse can last for over 10 million years, a surprisingly short time for astronomers but significant on a cosmic scale. As they search for clues about whether the bright star could become a supernova, astronomers have noted changes in its color. Some describe the star's hue as resembling Saturn's yellowish tint rather than Mars's reddish color. This raises the question: has the star's color changed? If so, it could indicate rapid evolution, suggesting a supernova could happen sooner than expected. This color shift offers a clue to the star's changes, helping researchers interpret cosmic events. Whether Betelgeuse undergoes a supernova soon or takes its time, humanity will have a spectacular view of one of the most extraordinary cosmic phenomena. What might happen if Betelgeuse went supernova? The possibility of a supernova appearing in our sky has captured the public's imagination. New simulations are helping astronomers understand what we could witness when Betelgeuse finally explodes, predicted within the next 100,000 years. However, uncertainty remains. Betelgeuse is around 500 light-years away, and recent research suggests that for a supernova to have a noticeable impact on Earth, the star would need to be within about 150 light-years. Around 2.6 million years ago, an event of this nature may have contributed to a mass extinction affecting marine life after the Permian extinction. If a supernova were to occur within 30 light-years of Earth, things could get precarious. However, Betelgeuse's supernova isn't expected to threaten life on Earth. There could still be some environmental effects. The explosion would release a surge of ultraviolet radiation, potentially causing a brief decrease in the ozone layer. However, research indicates that any resulting ozone depletion would likely be minor and short-lived, with limited environmental repercussions. Shortly after the explosion, we would detect weightless particles called neutrinos, which are harmless to us. The star would immediately become brighter, reaching a glow similar to the full moon within weeks. Betelgeuse's brightness would then wane, gracing our skies for about 6 months to a year. As it fades, it would remain a visible display for another 1 to 2 years before disappearing. Eventually, Orion would lose its red glow, a memory forever etched in human history. In the aftermath of a supernova, the explosion would generate cosmic rays, high-energy particles that can penetrate Earth's magnetic shield. However, except for the closest supernovae, these amounts would be relatively minor compared to other forms of radiation we experience. The supernova's final dazzling display wouldn't just captivate us, it would also create radioactive iron. Evidence of this iron, born from a supernova 2 to 3 million years ago, has been found in Earth's seafloor and even on the Moon. Fortunately, its proximity posed no significant threat to life on Earth. Such a nearby supernova is an extremely rare event, potentially occurring only once in a billion years. As speculation swirls around the potential appearance of a Betelgeuse supernova, astronomer Andy Howell from the University of California emphasizes the need for precise calculations. He enlisted the help of former graduate students Jared Goldberg and Evan Bauer. Their complex simulations portray the star's epic finale, combining uncertainties while drawing insights from observations of the 1987 supernova, SN 1987A. The closest recorded supernova in modern history. These astronomers concluded that life on Earth would remain safe, but the cosmic event would undoubtedly be unforgettable. According to Goldberg and Bauer's findings, when Betelgeuse ignites, its brightness will resemble the gentle glow of a half-moon, shining about 10 times fainter than the full moon. This mesmerizing brilliance is expected to grace our skies for over 3 months. Recent studies show that Betelgeuse is around 724 light-years away, safely outside the standard risk zone. However, the supernova could have fascinating implications for Earth. Howell notes that many animals rely on the moon for navigation and might be confused by such a bright object. Astronomers themselves would face challenges, as the intense brightness would exceed the capabilities of telescopes and space observatories. To compensate, telescopes would need to capture the subtler, softer glow of the star. Experts reassure the public that we would have sufficient warning if Betelgeuse goes supernova during our lifetimes. Earth's instruments would detect signals like neutrinos or gravitational waves produced by the explosion, giving us a heads-up as much as a day before the event. Although this event isn't likely to occur for another 100,000 years, Betelgeuse will eventually go supernova, and the outcome will depend on the materials left behind after the grand finale. As scientists continue refining their predictions and deepening their understanding of such cosmic phenomena, observations of similar stars at various stages of their evolution provide essential data for modeling the life cycles and potential explosive ends of massive stars. This information helps astronomers estimate the frequency and impact of supernovae in our galaxy, contributing to a broader understanding of cosmic events and their implications for nearby and distant celestial bodies. The study of Betelgeuse and other supergiants also aids in refining the cosmic distance scale. Accurate measurements of such stars' luminosity and behavior improve our methods for determining distances to faraway worlds, enhancing our overall mapping of the universe. Moreover, supernovae serve as vital tools for understanding the synthesis and distribution of heavy elements, such as iron and nickel, throughout the universe, elements essential for the formation of planets and life as we know it. In the meantime, space observatories are closely monitoring Betelgeuse and similar stars, using cutting-edge technology to detect any signs of imminent change. These efforts ensure that we are prepared to witness and study one of the most dramatic events in the life cycle of massive stars, enriching our understanding of the dynamic processes that shape the universe.